In this problem, light is in the air entering into a container of water with an angle of incidence of 36 degrees. We have the index of refraction of the water. What is the angle of refraction inside that water? So if you can picture, we have air, which has an index of 1. We have water, which has an index of 1.33. And we have our imaginary normal line or our origin here. And so this light's coming in, and inside the air, it's making an angle here of 36 degrees. Well, as it enters the water with a higher index, that angle is going to be reduced because the speed is reduced. And so we want to solve for what is that angle of refraction. And so we need to use Snell's law. The first index times the sine of the first angle equals the second index times the sine of the second angle. And we want to solve for that angle too. So I'm going to divide everything by the second index. And then I'm going to move this sine over. I need to take the inverse sine of all of that fraction. So inverse sine of, that's 1 right there, so you don't even need to put that in your calculator if you don't want to, times the index, or sorry, times the angle of incidence. I get my index and incidence words mixed up here in my brain here, divided by 1.33. So I'm going to do this fraction first, just the sine of 36 divided by 1.33. I'm going to take the inverse sine of that answer. And so we do get a smaller angle like we predicted, 26.2 degrees.